With the launch at lunchtime of the James Webb Space Telescope, a $10 billion project has taken 30 years to reach this moment, as well as distant planets which could provide evidence of life beyond Earth. Here's our science correspondent Rebecca Morell.
The James Webb Space Telescope had already established itself as the most ambitious space observatory humanity had ever constructed when it turned its gaze toward the interstellar visitor designated 3Y Atlas. This object, the third known interstellar body to cross into the solar system after the famous Oumuamua and 2I Borisov, carried an air of mystery unlike anything astronomers had encountered before. When Webb's instruments began sending back data, what followed was so disquieting that whispers soon spread of a decision from the highest levels to shut the telescope down. The event did not appear in press releases or official bulletins, but within scientific circles and speculative discussions, the notion that NASA might be hiding the true nature of 3I Atlas grew louder and more insistent. Before we start, smash the like and subscribe buttons for more updates. The Webb telescope was designed to peer deeper into the cosmos than any of its predecessors, capturing light in the infrared spectrum that reveals hidden structures behind veils of dust and distance. Turning this technological marvel toward an interstellar body was always going to raise expectations, but no one foresaw the scale of what emerged. 3. I-Atlas appeared at first to be a faint object, but Webb's sensitive instruments picked up unusual signatures, energy fluctuations, and spectral lines that didn't correspond to known models of cometary or asteroid composition. Instead of behaving like frozen rock and ice from the depths of another star system, the object reflected light and emitted radiation in ways that suggested artificiality. The more Webb focused on it, the more its data began to defy natural classification. At the heart of the controversy was what astronomers described as a patterned modulation in the energy emissions. Rather than random scattering or natural sublimation of volatiles, the object seemed to pulse in rhythmic intervals, as though transmitting a structured signal. The James Webb's high-resolution instruments recorded sequences that, when graphed, resembled repeating mathematical ratios. In astrophysical terms, such order is rarely if ever produced without intention. The implications struck like lightning across the community of researchers granted limited access to the raw Webb data. An interstellar object broadcasting in measurable sequences was something far beyond the paradigm of planetary science. It suggested either a naturally occurring phenomenon more exotic than anything ever theorized, or more tantalizingly and dangerously, it hinted at design. The question that quickly surfaced was why an observatory built at a cost of over $10 billion would suddenly be shut down, even temporarily, at such a critical moment of discovery. NASA's public explanations remained focused on routine calibrations, safe mode events, or unspecified technical issues. Yet the timing of these interruptions coincided directly with Webb's observation windows of 3I Atlas. Within closed channels, murmurs grew that this was not accidental. The agency, under pressure from defense interests and international scrutiny, had allegedly decided to stifle the most disruptive findings before they reached the wider world. If 3I Atlas was indeed more than a wandering rock, its existence threatened to unravel narratives about humanity's place in the cosmos. Scientists who saw even fragments of the early data described structures on the object's surface that looked angular rather than chaotic, shadows that repeated geometric forms, and emissions that mapped onto symmetrical distributions rather than random dispersals. Webb's deep field imaging had revealed galaxies forming only a few 100 million years after the Big Bang, but here it was peering at something within our own solar system that seemed no less profound. To acknowledge that an interstellar visitor carried hallmarks of non-natural construction was to leap across the boundary from astronomy into the realm of cosmic intelligence. The secrecy surrounding the event fueled endless speculation. Why would NASA, an institution built on transparency and scientific progress, choose to suppress such information? The answer lay in the magnitude of the implications. Confirmation of an object like 3I Atlas being artificial would not merely reshape astrophysics, it would destabilize geopolitics, religion, technology, and economics. Entire industries would confront obsolescence in the face of advanced extraterrestrial engineering. Governments might struggle to maintain authority over populations suddenly aware of civilizations beyond Earth. Shutting down Webb at the critical juncture could have been seen as an act of containment, a way to delay the inevitable until a narrative could be crafted. The data streams themselves were unlike anything expected from a cometary body. Typical comets vent gas and dust in arcs shaped by sunlight, producing chemical signatures of water, carbon dioxide, and other simple molecules. Yet Webb's spectrographs returned anomalies, rare isotopes in ratios not produced by stellar nucleosynthesis, compounds that appeared to resist decomposition, and energy emissions at frequencies reserved on Earth for high-efficiency communications. At one point, the telescope recorded a near-perfect triangular reflection, something not found in natural crystalline structures adrift through interstellar space. The researchers who viewed this described their sense of disbelief, their intuition telling them they were staring at engineering masquerading as geology. The more detailed the scans became, the stranger the narrative grew. Thermal maps showed regions of 3Y Atlas maintaining consistent temperature, despite exposure to fluctuating solar radiation. Instead of heating and cooling like inert matter, sections of the body seemed regulated, as though some mechanism kept them stable. In human terms, it resembled shielding or insulation, properties designed with intent. The James Webb, capable of detecting exoplanet atmospheres light years away, had stumbled upon something in the near backyard of the solar system that refused to conform to physics as understood. The decision to shut down Webb was not merely a technical maneuver, it was a statement. By halting observations, by labeling data as corrupted or incomplete, those in authority created a barrier between knowledge and public access. Within the halls of power, the logic may have been clear: avoid panic, avoid premature conclusions, buy time to evaluate. But to those aware of the suppression, it represented the silencing of discovery itself. A machine built to bring humanity closer to the truth of the cosmos was being held hostage by the very institutions meant to foster that truth. The implications of what Webb saw with 3Y Atlas cannot be overstated. If the object was truly artificial, then it was not merely passing through. It was a messenger, a remnant, or even a probe. The fact that it traveled interstellar distances implied a level of endurance and design unmatched by anything humanity had ever achieved. A probe drifting between stars suggests intentional placement. Perhaps an ancient mission launched millennia before Earth's civilizations arose. The possibility that it carried information, or that its signals were meant to be intercepted, raised further questions. Were we observing it by chance, or had its trajectory always been intended to intersect with our awareness at this precise point in history? Beyond the scientific community, the cultural weight of such a revelation would be seismic. Faith systems rooted in Earth as the singular focus of intelligent life would encounter challenges unlike any before. Political structures might race to weaponize the discovery, treating the object not as a chance for knowledge but as a potential resource or threat. The suppression of Webb's data, then, could be interpreted as an effort to prevent these cascading consequences from igniting before governments had a plan in place. Yet suppression rarely holds forever, and the truth of 3I Atlas, once glimpsed, cannot be entirely erased. For astronomers, the frustration was acute. The James Webb Telescope was not just a machine, it was a dream realized, decades in the making, and every moment it was pointed at an enigma like 3I Atlas was a chance to expand the horizon of human knowledge. To have that opportunity shuttered under the weight of secrecy represented more than censorship. It symbolized the tension between open science and guarded power. The data was too strange, too consequential to vanish into silence without leaving behind ripples in the scientific community. Researchers whispered, shared fragments, and debated behind closed doors, each trying to piece together what had been glimpsed in those brief moments of cosmic clarity. The extraordinary aspect of the situation is that Webb had been designed not to miss such anomalies. Its instruments were tuned to detect faint chemical fingerprints, delicate heat emissions, and minute fluctuations in light. If any observatory could have confirmed the existence of non-natural interstellar technology, it was Webb. The sudden cessation of its work on 3W Atlas therefore carried the weight of deliberate choice, not technical failure. And that choice was made not in the name of science, but in the name of control. The story of Webb and 3I Atlas lingers as a reminder of the fragile balance between discovery and secrecy. Humanity's instruments now reach into realms once reserved for speculation, capable of unveiling truths that can destabilize the foundations of civilization itself. When confronted with evidence that challenges the deepest assumptions about life in the universe, Those holding authority must decide whether to reveal or to conceal. In the case of 3I Atlas, the decision was concealment, enacted through the silence of a $10 billion telescope suddenly blind to the most extraordinary object it had ever encountered. And yet, no matter how carefully the shutters are drawn, the light of such discoveries has a way of escaping. The rhythms recorded in Webb's brief scans, the geometric forms traced in its imagery, the thermal anomalies documented before the shutdown, all remain seeds of possibility. They suggest that the cosmos is not empty of design, that across the gulf between stars, intelligence may have left its marks, waiting for us to notice. The shutdown may have delayed the public recognition of this fact, but it cannot erase the implications of what was seen. For those who glimpsed the data, 3I Atlas was not a comet, not a rock, but a question so vast that even the silence surrounding it cannot diminish its resonance. When the James Webb Space Telescope turned its attention toward 3I Atlas, the sheer audacity of the act was staggering. Here was a machine orbiting 1,000,000 miles from Earth, cooled to frigid temperatures to capture faint heat signatures from the dawn of time, and it was being asked to examine a fleeting traveler from beyond the solar system. 3I Atlas had already captivated astronomers because of its trajectory. It was hyperbolic, meaning it was not bound to the sun's gravity and would never return. Unlike asteroids or comets we knew well, this was a stranger, a visitor passing through, bringing with it the untouched history of another star system. That history should have been written in the ice, dust, and rock clinging to it. But Webb revealed something else entirely. The telescope's first scans picked up peculiarities. Instead of random outgassing, the hallmark of comets heated by the sun, there were localized plumes that seemed to emerge in deliberate bursts. Some jets appeared to align with its motion, as if altering its trajectory fractionally rather than acting as simple sublimation. Engineers and astrophysicists alike struggled to explain why a natural object would shed material in a way that resembled thrust. The plumes did not match the chemistry of known cometary bodies either. They included compounds with high melting points that should have been stable, not vaporizing in space. The irregularity of it all was what unsettled those first reviewing the findings. Webb then directed its spectrographic instruments to analyze the surface and emissions. What came back was baffling. In one sector, the telescope detected sharp discontinuities in the spectral lines, as though the material was not a continuous mixture, but layered in deliberate composition. Natural rocks display a scatter of elements based on their stellar nursery. 3I Atlas, however, looked stratified. One layer emitted a dominance of nickel iron, another reflected unusual ratios of silicates, and beneath that appeared compounds that, on Earth, would be associated with engineered alloys. The phrase unnatural geology began to circulate quietly among those allowed to glimpse the raw readouts. What the Webb was seeing was not chaotic, it was structured. As Webb continued its observations, another anomaly emerged. Reflective patterns that created interference in the telescope's detectors. Normally, light bouncing off a jagged surface produces noisy scatter. But this object produced coherent reflections, almost like polished panels or facets. The interference caused the detectors to register harmonics that repeated predictably. When graphed, the signals formed grid-like sequences, something closer to engineered radar reflections than the messy echoes of a natural body. At that moment, speculation crossed the line into conviction for some of the scientists. This was not just another interstellar rock. Something about it was broadcasting an unmistakable signature of intention. Why then was this information so quickly sealed away? The James Webb Telescope was built on global collaboration, with Europe, Canada, and the United States all sharing in its construction and operations. Shutting down its observations of 3I Atlas required a coordinated directive, not a simple technical glitch. The timing was conspicuous. Every time Webb was trained on the object during its closest approach, the telescope entered safe mode or reported unstable orientation, despite operating flawlessly for other targets. To those watching carefully, the pattern was too precise to ignore. The most advanced telescope humanity had ever constructed was effectively gagged by those in charge. The reasoning for such an action lay not in science but in consequence. If Webb's findings had been published in their raw form, every observatory, every academic, and every amateur with the technical means would have pounced on the data. Peer-reviewed journals would be flooded with analyses pointing toward artificiality. The notion of interstellar technology would no longer be fringe speculation, but an evidence-based conclusion. Governments and agencies were not ready for that leap. They feared chaos, feared the collapse of established hierarchies, and perhaps feared the strategic implications most of all. If 3Y Atlas carried even the suggestion of alien engineering, then the race to control or exploit its secrets would ignite immediately. The peculiar geometry Webb hinted at added fuel to this fear. One captured image, partially leaked through unofficial channels, displayed a region of the object shaped in near-perfect right angles. Nature does not favor such precision on small scales. Erosion, impact, and chemical activity tend toward irregularity. Yet here, nestled in the surface, was a cornered recess with symmetry that defied coincidence. Paired with thermal data showing regulated temperatures in that region, the impression grew of an internal compartment, a cavity maintained against the harshness of space. Whether it was hollow or contained something no one could confirm, but even the suggestion of it destabilized those reviewing the scans. Observers noted too that 3Y Atlas seemed to respond subtly to solar radiation pressure in a way that amplified its trajectory changes. Natural bodies are pushed gently by sunlight, but this object's acceleration exceeded what its size and shape should have allowed. It reminded many of the peculiar acceleration of Oumuamua years earlier, which had already sparked debates about alien probes. Webb's superior sensitivity now gave sharper evidence of such anomalies, but unlike Oumuamua, which was already gone when suspicions grew, 3I Atlas was modulating it deliberately. Those pulses, when analyzed, produced harmonic ratios aligned with prime numbers. For scientists trained to recognize signs of intelligence, this was a thunderclap. Prime sequences are a universal marker, used in theoretical scenarios for communicating with extraterrestrial intelligence. Here they were, blinking softly from a body drifting through the solar system. The implications were cosmic in scale. If the object was transmitting or even designed to leave such traces, it meant someone, somewhere, had constructed it. Its age and trajectory suggested it had been launched millennia ago, perhaps tens of thousands of years, a time capsule from a civilization predating human history. That civilization might no longer exist, or it might still be thriving light years away, having seeded the galaxy with messengers like this. The prospect opened possibilities that stretched human imagination to breaking. No longer would the universe be silent. It would be alive with the artifacts of intelligence awaiting our recognition. This realization also posed urgent questions about intent. If 3I Atlas was indeed a probe, was it passive or active? Was it merely drifting as a relic, or was it functioning, recording, perhaps even observing us? The pulses Webb picked up might have been beacons, signals intended for detection by any capable species. Alternatively, they could have been communications directed elsewhere, relayed across the stars. Some speculated that by observing and decoding them, humanity might already have stepped into a conversation far larger than itself. The ethical dilemmas were immense. Should the signals be answered? Should the data be concealed? Or should the world be told of the encounter? Shutting down Webb can be seen in that light as a choice of caution. To reveal the full scope of what was found risked sparking a global frenzy. Governments, fearing a loss of control, preferred silence. By declaring Webb offline during critical observation windows, they bought time. Time to interpret, time to strategize, time to decide how much of the truth to let slip. In the meantime, astronomers and citizens alike were left in the dark, their questions redirected to technical explanations that rang hollow. The suppression, however, only magnified interest. Independent observatories attempted to track 3Y Atlas, but none possessed Webb's sensitivity. Ground-based telescopes caught glimpses, but Earth's atmosphere distorted the faint signals. Radio telescopes scanned for transmissions, but whatever Webb detected in the infrared remained out of reach. This asymmetry in knowledge created suspicion. Only those in control of Webb knew the full story, and they were not talking. The silence paradoxically made the revelation more believable. Why gag the telescope unless it had indeed found something unexplainable? For scientists devoted to open inquiry, the event represented a bitter irony. The James Webb Telescope had been built to answer humanity's most profound questions. How did the universe begin? What lies in the atmospheres of distant worlds? Are we alone? Yet when faced with evidence that touched directly on that final question, the telescope was muzzled. The very success of its design had made it too dangerous to wield openly. It was as if the cosmos had whispered an answer, and humanity had covered its ears, terrified of what might follow. The cultural implications alone would have been staggering had the data been released. Religions might have interpreted the object as a sign, a vessel of celestial beings, or a long-awaited revelation. Philosophers would have debated its meaning for humanity's place in the cosmos. Artists, writers, and storytellers would have drawn inspiration from the tangible proof that intelligence had crossed the stars. Economies would have reacted to the possibility of alien technology, speculating wildly on what could be learned or harnessed. Militaries would have eyed the object with suspicion, fearing it as a threat or a prize. And ordinary people, staring at the night sky, would have done so with new awareness, knowing that something out there had crossed into our neighborhood, carrying secrets we could not yet grasp. The irony is that the shutdown itself became part of the story. Instead of quietly allowing 3I Atlas to pass unremarked, the silencing of Webb ensured the event would echo for years. The gaps in data, the suspicious timing, the leaks of partial findings, all combined to form a narrative of concealment. In the long arc of history, this act may be remembered not as a suppression of knowledge, but as the moment humanity first realized how extraordinary 3I Atlas truly was. The truth, even hidden, leaves shadows that point toward its shape. As 3I Atlas slipped further from the solar system, unreachable and fading into the deep, Webb's lenses were turned back toward galaxies and nebulae. Official reports resumed with triumphs about star formation and exoplanet atmospheres. But for those who had glimpsed what lay in the brief intersection of telescope and traveler, the universe would never look the same again. The silence of Webb did not erase the sight of structured emissions, geometric surfaces, and rhythmic pulses. It only ensured that the mystery deepened, unanswered, and unresolved. The legacy of this event lies not only in the data collected, but in the questions it ignited. If 3I Atlas was artificial, then surely it was not alone. The galaxy, vast beyond comprehension, might be seeded with such messengers, drifting patiently, waiting to be noticed. Webb may have been silenced, but other instruments, other missions, will one day follow its path. The truth has a way of resurfacing, and when it does, the memory of how it was once hidden will linger as a cautionary tale of fear, outweighing curiosity. Even now, in the wake of the shutdown, the implications ripple outward. Scientists wonder if Webb's glimpse was a missed opportunity to decode messages written across eons. Engineers dream of sending missions to chase such objects, to intercept and study them up close. Thinkers across disciplines wrestle with the possibility that we are latecomers to a cosmic dialogue already in progress. And somewhere in the archives of data locked away from the public eye, the fingerprints of that dialogue remain, silent yet indelible. What Webb revealed about 3I Atlas was never just about astronomy. It was about humanity's threshold moment, when the question of whether we are alone brushed against the edge of answer. By shutting down the telescope, that moment was deferred, not erased. The event lives on in speculation, in whispered accounts, in the uneasy awareness that something extraordinary passed through our skies and was glimpsed only briefly before being hidden. And perhaps that is the greatest implication of all, that the universe does not wait for permission to reveal its wonders, and that even when we turn away, the truth remains, vast and patient, beyond the reach of silence. The James Webb Space Telescope had been commissioned as a window into the earliest chapters of the cosmos, a tool designed to look back billions of years in time. Yet, in its fleeting examination of 3I Atlas, it turned into something far more disruptive, a witness to the immediate and unsettling unknown. What made this episode extraordinary was not just what Webb recorded, but the rapidity with which the information was locked down. The act of halting a $10 billion instrument spoke volumes about the stakes. To stop science at the very moment it was doing what it was meant to do was not merely operational, it was philosophical. It was the drawing of a line between what humanity was permitted to know and what it was not. One underexplored dimension of this event lies in the question of scale. 3I Atlas was not large by astronomical standards, comparable in size to a small mountain. But Webb's readings hinted at density fluctuations far exceeding expectations. The telescope's instruments suggested the body contained materials of extreme compactness, denser even than typical metallic asteroids. This created a paradox. an object small enough to slip through the solar system unnoticed for years, yet massive in a way that distorted nearby dust trajectories. Observers noted faint arcs of particles being deflected in patterns that hinted at internal structures designed to manipulate gravity or magnetism. In natural terms, such behavior was implausible. In technological terms, it was tantalizing. Another point of fascination came from the surface reflectivity. While comets and asteroids usually absorb most incident light, darkened by carbon-rich compounds, sections of 3I Atlas shone back at Webb with extraordinary albedo. Some regions reflected up to half the incoming sunlight, a figure closer to polished metal than cosmic rock. Even stranger, the reflectivity was not uniform. It varied across straight boundaries, as though sections had been tiled or segmented intentionally. Natural worlds wear their scars in chaos. This visitor carried what looked like the fingerprints of design. The timing of 3I Atlas's arrival also invited scrutiny. Humanity had only just deployed Webb after decades of delay and engineering battles when the interstellar object appeared. Critics of suppression argued that it was too coincidental for the most powerful telescope in history to encounter such an anomaly so soon after activation. Was it chance, or had the object been deliberately routed through our system when it could be noticed? The hyperbolic trajectory left no doubt it had come from beyond, but trajectories can be manipulated. If 3I Atlas was a probe, its path might not have been random at all. It could have been designed to intersect with a civilization on the verge of attaining instruments capable of noticing it. There was also the matter of its silence, or what passed for silence. Radio telescopes across Earth swept the skies during its approach, but they reported no artificial transmissions in conventional bands. Yet Webb, operating in the infrared, detected those pulsing emissions, the thermal signals repeating with mathematical regularity. To communicate in heat rather than radio suggested an entirely different framework of thought. Perhaps whoever sent it understood that civilizations first develop infrared astronomy before building massive radio arrays. Or perhaps the signal was never intended for us at all, merely an artifact of its functioning. Either way, Webb's sensors caught something invisible to terrestrial instruments, and that something was enough to trigger alarm. The controversy surrounding Webb's shutdown brings into focus the question of stewardship. Who owns the right to cosmic discoveries? The telescope was an international collaboration, funded by the United States, Europe, and Canada, and celebrated worldwide as a beacon of collective human achievement. Yet the decision to halt its observations of 3I Atlas appeared to come from a narrow circle of authority. This concentration of control highlighted an old tension. Is space science a global endeavor, or is it subject to national interests? If Webb glimpsed alien technology, was it a discovery for all of humanity, or a resource to be hoarded by a few governments? One of the most overlooked details from the limited leaks was the observation of rotational stability. Most interstellar objects tumble chaotically due to collisions in their past. But 3I Atlas rotated with an almost mechanical precision, maintaining a stable spin axis over extended observation windows. This kind of stability could occur naturally, but it is exceedingly rare. For engineers, it evoked the image of a spacecraft designed for endurance, maintaining orientation deliberately to prolong functionality. Combined with the thermal regulation noted earlier, the rotation suggested maintenance of internal systems over unimaginable timeframes. If such a probe existed, what might its age be? Its hyperbolic velocity indicated it had traveled for millions of years, perhaps longer. At such scales, the notion of sender and receiver collapses. It could have been launched by a civilization long extinct, its creators gone while their creation still wandered. Or it could be part of a vast network, a chain of messengers drifting between stars, exchanging information like pollen carried by interstellar winds. The idea that Webb might have briefly glimpsed one of these cosmic couriers imbued the object with a sense of melancholy grandeur. It was not just an artifact. It was a story written across the void. The handling of this revelation raises ethical dilemmas as profound as the discovery itself. If 3I Atlas was indeed an artifact, should humanity seek to intercept such objects in the future? Missions could be designed to launch interceptors, to drill, to capture samples, but doing so risks tampering with relics not ours to disturb. Some voices in the scientific community argued that contact with such probes should be approached with reverence, as though encountering archaeological remains of a species across time. Others insisted that knowledge demanded boldness. The potential advances in technology, energy, or communication were too great to ignore. By shutting Webb down, those in charge denied the world even the chance to debate these questions openly. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on NASA hiding 3 iAtlas discoveries from the public? We want to hear from you. Thank you for watching and see you next time.